Hello everyone, my name is Dr. Joseph Hammer, and this is a practice run of a talk I'll be giving at the American Psychological Association annual convention in August 2018. It's entitled, Using Bifactor Analysis to Clarify the Structure of Psychological Constructs, a Masculinities Case Study. So here's the problem. Generally, instruments are good at reliably measuring either a single overall construct, such as with a total score, or specific facets of an overall construct, such as with subscale scores. We can't have our cake and eat it too, according to some psychometricians. Factor analysis studies of popular instruments often provide conflicting evidence about the unidimensionality versus multidimensionality of those instruments. So a possible solution is bifactor analysis. It can help resolve instrument dimensionality debates. And dimensionality is important to know because the dimensionality of your instrument, whether it's unidimensional or multidimensional, that can dictate how you can score the instrument properly, such as do you use total scores versus subscale scores. And the reason we care is that we make important clinical funding and policy decisions based on scores from psychological instruments. We make decisions about prisoner parole, child entrance to talented and gifted programs, whether someone will get disability accommodations, etc. And if you have invalid or unreliable scores, this can lead to misinformed decisions, and such decisions can really hurt people or hold them back, especially marginalized folks. The bifactor analysis approach, in this talk, I will briefly give you a glimpse of how you can use it alongside ancillary bifactor measures to answer questions like the following. Is the instrument mostly unidimensional, multidimensional, or somewhere in between? Can I use the total score that this instrument supposedly produces to accurately measure the overall construct? And likewise, can I use subscale scores to measure the specific dimensions of the construct that they're supposedly measuring? I'll take today's example from a paper that my colleagues that my colleagues and I recently published in the Psychology of Masculinity. So, the focus of this paper was the CMNI 46, and it measures how much a person conforms to white westernized standards with which people deem men's behavior as acceptable or unacceptable. Specifically, we'll get to that in a second. Two samples were used. We had a sample of adult men and a sample of male college students from researchmatch.org and SUNA subject pool, respectively. They were mostly white folks. The CMNI 46 has 9 subscales, so it measures degree of conformity, self-reported conformity, to these 9 masculinity norms. You can see some examples here, such as emotional control, and there's an example item, I never share my feelings. So there's a bunch of masculine norms that are white and westernized that people have ratings on. So for the first question that we asked, is the CMNI 46 mostly unidimensional, multidimensional, or somewhere in between? And the approach we take is we test competing confirmatory factor analysis models. And then we consult ancillary bifactor measures pertaining to dimensionality. Here's what a unidimensional model of the CMNI 46 looks like. Those tiny boxes down there, 46 of them, those are the 46 items, and they're all thought to be explained by one higher order conformity to masculine norms construct. That's what the unidimensional model specifies. In contrast, a correlated factors model says for those 9 norms, we have 9 factors upon which each set of items related to that factor load. So these 9 factors are thought to be related to each other because generally if you endorse one flavor of masculine norm, you tend to also endorse to differing degrees some of the other ones. So that's what all those arrows at the top are. It says these degree of conformity on these norms tend to be related to each other. A second order factor model builds on the correlated factors model, and it says the reason why these 9 subfactors correlate with each other is because they're all dictated by or driven by or explained by a higher order conformity to masculine norms construct, which then dictates the 9. In contrast, we have the bifactor model, which takes some time to understand. A bifactor model is a model with a broader general factor, you can see it there at the bottom, and narrower specific factors, you can see them at the top. These factors compete against each other to account for variance in the 46 items. To specify a bifactor model, I tell my structural equation modeling software, such as M+, that each item should load on the general factor as well as one of the specific factors to which it is assigned. Thus, each item loads onto 2 different first-order factors simultaneously. The most important thing to know is that the bifactor model, unlike the second-order model, forces the items to choose a side, so to speak. Each item must decide how well it will measure the general factor and how well it will measure the specific factor. We force items to play this zero-sum game when we do a traditional bifactor model, and there are others, but when we do a traditional bifactor model, we force them to play this zero-sum game because, number one, it helps us determine whether an instrument's total score is truly measuring the overall construct, or if it is attempting to measure an overall construct that doesn't actually exist, that's really weak, perhaps, and that can't be measured reliably. Number two, it helps us determine if an instrument's subscale scores are truly measuring the specific dimensions they are supposed to measure, or if they're merely remeasuring the overall construct without us realizing it, in which case they're extraneous. So, question 1 again, we start with testing competing CFA models. So with our data, we found mixed support for correlated factors and bifactors models. So both the correlated factors and the bifactors models looked okay per global fit statistics. And again, we used 2 samples, so we had 2 sets of results. When the bifactor model fits at least adequately, I suggest consulting ancillary bifactor measures. Duber's calculator, you can find it at that link, is a wonderful way to do this. We used to have to manually code this into M+, but now you can just copy and paste the standardized loadings from the unidimensional factor solution from the bifactor solution into the proper columns. This is just one little spot of a larger Excel spreadsheet that I took a picture of, but you can see some of the standardized loading copied and pasted for the items on the various factors. And Duber's calculator provides a wealth of ancillary bifactor measures. I'll mention a few here. For the dimensionality results, about 90% of the 46 items measured their assigned specific factor better than they measured the general factor, as was captured by the IECVs, the individual explained common variances, being less than 50. Likewise, the general factor explained only about 18% to 27% of item variance, as captured by the explained common variance for the general factor coefficient. Treating the CMNI 46 as unidimensional would lead to biased factor loadings per the ARPB, which generally you do not want to be higher than 10 to 15% if you're hoping to treat an instrument as unidimensional. But these values from the 2 samples were above it, so we can't treat it as unidimensional. In summary, looking at these things collectively, and it takes some practice to figure out how to look at these sets of results collectively and figure out what they mean. But in sum, the CMNI 46 is clearly multidimensional, not unidimensional. And an overall conformity construct doesn't seem to be measurable, at least with the CMNI 46. Thus, a correlated factors model would be best to use for the CMNI 46 going forward. That's what we determined. Question number 2, can I use the raw CMNI 46 total score to measure overall conformity? Now, if a correlated factors model is retained, which is what we had in this case, the answer is automatically no. But let's pretend the bifactor model was the one we retained. In that case, we'd consult ancillary bifactor measures pertaining to model-based reliability of that total score. And we went ahead and did that just to be exploratory. And we saw in our two samples that the raw CMNI 46 total score is a borderline reliable measure of overall conformity. And the omega hierarchicals were 0.58 and 0.71. Generally, the suggested minimums range from, on the low end, 0.50 or greater to, on the high end, 0.75 or greater. And you can sort of think of omega hierarchical like a Cronbach's alpha, where generally you want to see it above 0.70. Most bifactor scholars would conclude that the raw CMNI 46 total score, given that 0.58 and 0.71, are not sufficiently reliable measures of overall conformity. They really should be higher for a total score. Question number 3, can I use the 9 raw CMNI subscale scores to measure conformity to the 9 specific norms? And again, if correlated factors model is selected, which was the case, the answer is automatically yes, assuming those Cronbach alphas you calculate for the subscales look okay, which they did in this case. But again, if we wanted to be exploratory, if a bifactor model is selected, you can look at model-based reliability of the subscale scores. So we checked that out. Some raw CMNI subscale scores are reliable and some are not. They range from 0.35 to 0.78 on the omega hierarchical subscale coefficient. The suggested minimums, again, are 0.50 to 0.75. I like the relative omega hierarchical subscale, which takes overall reliability into account. And I like the criterion of 0.75 or above as a good cutoff. Using that cutoff, we found that about 7 of the 9 raw subscale scores would be deemed sufficiently reliable to warrant their future use. So, in conclusion, use a correlated factors model with the CMNI 46. That's what we determined. We did not find evidence of an overall conformity construct, and that's important because several scholars had been treating the instrument as if it could measure an overall thing, and they were using a total score. But we didn't find evidence that supports that sort of use. But we did find evidence of 9 specific masculine norms that can be appropriately measured with the subscale scores. Here are some key bifactor references I really recommend, and thank you for your time. You can find more information about bifactor analysis and see several applications of bifactor analysis in a variety of domains. You can go to my website at drjosephhammer.com. Thanks.